Hello, friends. I welcome everyone on the platform by Uniting Power Engineers. And we are going to start our webinar series number 38. This time on a very important topic of basic concepts of transmission control and protection. And we are going to have this important topic with very intelligent, very practical, and insightful presenter Mr. Abhishek Chotaliya ji. When we talk about the power transmission systems, basically this is the backbone of electrical grid that ensure that the power generated at remote and at the power generating stations reaches the consumers. These systems transport electricity from generating station to substation and further to the consumers through distribution network. Power transmission control and protection are the critical for ensuring the reliable and the safe delivery of electricity across grid. Transmission control involves regulating voltage, current, and frequency to maintain stable power flow. When I say power flow control, that ensure the electrical power is transmitted from generating source to the load in a manner that is efficient and reliable. We use many devices like breakers, relays, transformers to manage power transmission efficiently. And to manage the power flow, we use many devices like phase shifting transformer, FEX, HVDC, etc. When we talk about the protection systems, these detect faults such as short circuit, overload, equipment failure, and finally helps us in isolating the affected sections to prevent further damage. When we talk about the protection systems, the main relays that comes in the minds of all engineers are overcurrent, differential relays, distance relay. Apart from that relay, various protection schemes are also implemented to enhance reliability and the efficiency of power transmission system. And these schemes includes backup protection, zone protection, busbar protection. Advanced protection systems in the recent years with the advancement in the technology have led to development of more sophisticated protection systems that includes digital relay, PMU, wide area monitoring and protection systems. When we talk about all these protection and control, this always comes with some challenges. If we have to talk about the challenges involved with this protection and control, the first challenge in that category is the integration of renewable energy. Cybersecurity, the second important issue we have to address, and third is the aging infrastructure. Retrofitting of my digital systems with already existing systems is a big challenge. In short, effective control and protection reduce risk, enhance system reliability, and ensure continuous power supply. To talk about fundamentals, control, and protection, and the challenges involved, I am with experienced Abhishek Chotaliya from GetCo, who has already rendered his 19-year service in different capacity. He started his career in 2006 May. Presently, he is working as a deputy engineer, operation and maintenance, also working as a faculty trainer for Gujarat Energy Transition and Research Institute, GETRI. If we talk about the achievement he has already achieved, he has played a key role in the planning and executions of constructions of many substations and lines. He has worked as a ISO internal auditor and ISO lead auditor for ISO. He has successfully completed executive management program at PDPU Gandhinagar. He has developed a process and Excel program for routine work, load minimization. The important thing is that successfully contributing knowledge to the electrical community by creation of insightful videos on the YouTube. Inside Tech is the name of the YouTube he is running, having 38,000 subscribers so far. Last but not the least, he's a person with a goal to empower energy power transmission professional with knowledge and the confidence needed to strengthen and contribute to a nation, India, and a national power grid. I always start with thanks to my Almighty, my family, my mentors, my team who are supporting day in, day night to make all these webinars happen. And now, without further ado, I would like to invite Abhishek ji. Kindly fill this stage with the knowledge you have. We are very excited to hear from your side right now. Stage is yours right now. Thank you, sir.
Thank you, sir. Thank you very much, sir. Uh, as sir have mentioned, the power required to transfer from one state to another state, and it requires control, right? So we are basically today we will talk about the control and protection of the power system in very basic manner, right? Let me share my
Please,
screen
please.
first.
Perfectly okay, sir. Sir, you are mute. Unmute yourself. Abhishek ji, you are on mute.
Yeah.
Now it's okay.
So today we'll see the basic concept that how the transmission and the transmission control and protection works, right? Then let me start. So as sir has mentioned that the power should be transmitted from one point to another point, and which will go like this, right? But this is the uncontrollable power, right? You can't control this, so you need to control this power by providing a breaker switch between these two stations, right? So there is a breaker which operates like our home switch. When switch we open this on the switch, the light ignites, right? So in power system there is a EHV lines and EHV switches which are called breakers, which is operates by some force. uh, there will be a mechanism to operate the breaker, and the mechanism will get power from the springs or some other maybe that air or another thing. So here it is a spring which give power to operate the breaker, right? Then the spring will operate by a motor, right? So there is a motor which charge the spring, and motor requires AC power. So one of the auxiliary supply is AC for the breaker, and to operate this breaker we have one closing coil which is powered by DC power, and a tripping coil which is powered by also a DC. Okay, now we required a TNC switch which operates the breaker, trip or close, right? But these all things are manually. Okay, we need to operate breaker to on position or off position. Yes, we require to on the breaker by manually, but it should be tripped automatically. Whenever the power more power is consumed by the another station, then it should be operate due to the uh, our line parameters. Okay, so we need require a relays, and the contact of this relay is also connected here to operate the TNC switch. Okay, so this is the total basic transmission system which we are operating in whole grid. Today we will see some of these parameters, how they works and how they are useful in our power system. So firstly, we are we will see how the control panels and the switchyard equipments are connected. These are connected by wiring between control panel and switchyards. So let's see the control panel. What are the equipments in the control panel? Firstly, there is the semaphore, which indicates breaker on or off position. Then there is the annunciator. If something is happened in our system, then annunciator will annunciate that these things are happening. Then these are the meters to uh, monitor the power transfer. Then these are the indicating lamps which indicates some of the parameters of the transmission system, breaker conditions and others. We have seen a TNC switch which is trip neutral closed switch to operate the breaker. Then there is a differential relay, as this panel is of transformer panel. So the differential relay is here, and another one is backup relay. Then some another relays like three elements relay which called auxiliary relays, then TCS relays, trip circuit supervision relay, and a master relay. Then test terminal blocks which are used to test some things like energy meter or relays, and one energy meter, that is the kWh meter, which will measure the power transfer. Okay, then to measure the power transfer we required something that is called CT and PT. We first will see the CT. CT are the current transformer. They are looking like this. There is a black conductor, that is the primary of current transformer, and these three are the secondary of current transformer. The current transformer has three secondaries, that is metering core, protection core and special protection core. Basically the P1 and P2 is the primary contact of this current transformer, and here the 1s1, 1s2, 1s3, that is the secondary contact of our first core. Okay, here it is written that this CT is 600-300 by 111. That is mean this is the dual CT ratio, right? So same CT can be used in 600 ampere and 300 ampere. The 3-1 shows that this CT has three secondary cores, that is metering, protection and spatial protection. What is that? So 1s1 and 1s2, between 1s1 and 1s2 we will get 300 by 1 ratio, and between 1s1 and 1s3 we will get 600 by 1 ratio for the CT. Okay, then what is this metering protection and special protection core. So here that is differ by accuracy class of the CT secondary core. So first core is zero point 0.5 class that gives 0.5% error at 100% uh, flow. The second is the 5P10 that is a 5% error at 10 times current flow from the CT. And the third one is the special protection, which has high knee point and which is used in very accurate protection like distance protection or differential protections. When we see the wiring of these CTs, so here you can see that there is three CTs, R phase, Y phase and B phase, and the first core of these CTs are used here where 1s1, 1s2, that is R1s1, 1s2, R1ys1, s1, 1s2 and B1s1, 1s2. So this is the metering core and how it is connect to the CTMK box. Let's see. So this is the connection of the first core of the CT, and from the MK box we will take 4 wires to the control panel. That will be the D11, D31, D51 and another 3 will be short and earth, that will be our neutral. So this is R phase, Y phase, B phase and this is neutral. So these 4 wire will go to the panel. Likewise, as we see the 3 phase CTs, then here is the 3 phase CT, R phase, Y phase, B phase, and all the wirings of these CTs is done like this. As we have seen, the first core is connect like this, then the second core will be connect from 7 to here 12, and the third core will be 13 to 70. Then the 4 wire for metering, 4 wire for protection and 4 wire for special protection core will go to the control panel. Okay. So how the 4 wires will work in the control panel? As these 4 wires come from CTMK box, it will come to the panel, and in the panel there will be a test terminal block which we have seen earlier. Then the kWh meter, that is the energy meter, then megawatt meter, MVR meter and ampere meter for each phase. Okay, then how it connect? It will connect like this. The D11 will go to TTB, then it connect to kWh meter, then it connect to MWH meter, MW meter, MVR meter, and ampere meter. And after ampere meter, it becomes neutral and connect to the neutral. So the CT connections for 3 phase are like this, and the CT is continuously connect from phase to neutral with connection to the each and every equipment. The current flow will be like this. Here the TTB is the test terminal block for the kWh meter. So you can bypass the kWh meter for testing purpose. So that connection will be done by TTB just like this. When we bypass the energy meter, the CT will be passed through MW, MVR and ampere meter and then go to the neutral. So you can test the kWh meter. Okay. So this is the metering circuit inside the panel of control panel of the power system. Then the PT. PT, that is the potential transformer, which converts voltage, higher voltage to low voltage. Generally, it is from 66 kV to 1110 volt and so on. Okay, in which there is a primary A to N, and here is the secondary. There is a two core in the secondary. One is metering core and second is protection core. Okay, it will nomenclature like first core for 1A 1N, second core 2A 2N. Now these two cores is also separated by accuracy class. The first core is 0.5% error at the 100% voltage, and the second core is 3P, uh, and 3P is 3% voltage ratio error and 120-degree phase displacement. Okay, the connections of the three-phase PT is done like this. For the metering, 1A will be connect to here and 1N will be connect here. So on Y and B phase, and now the four numbers of wires will go to the panel from the PTMK box, which will E11, E31, E51 and E71, that is R phase, Y phase, B phase and neutral, same like CT. Okay, and the secondary core is also connect like this. Here E11 voltage between E11 and E31, that will be 110 volt, and uh, the voltage between phase yani E11 and E71, that will be 63.5, as our CTs are 66 by 110 volt ratio by root 3, right? Now, how the PT is connect in the control panel. So same thing, all the measuring equipments requires CT and PT both. So the PT come to the TTB, that is the test terminal block, then kWh meter, then MWH, MVR meter and voltmeter, right? So this is the connection of PT to the metering circuit. Here you can see that the PT is connect parallelly to all the equipments, as the CT are connects seriously, right? And here is the VSS, that is the voltage selector switch, that will give the voltage whenever you select the switch from RY. So it will indicate the voltage between R and Y, and R neutral, then it will indicate R and neutral. Okay, and this is the neutral connect to the earth. Okay, now backup protection. So the PT is also used for backup protection in case of our directional earth fault relay. Okay, and also it is used in distance relays. So this both relay required PT to manage the fault condition. Okay, now we'll see the test terminal block, how it is works. Okay, the test terminal block is like this or like this. This is the oldest one and this is newer. Uh, let's see the how it works. Okay, this is the diagram of test terminal block where the our CT and PTs are comes. So here D11 from CT comes to here, then it go to energy meter. This is the energy meter, and return at here and back to neutral from here. Okay, just like this, all three phase are connect, and PT are go to energy meter via these pins. Okay, now how the current will flow. So current will flow like this in case of energy meter is in service. Okay. Now whenever you want to uh, test the energy meter, you need to connect here uh, a screw. There will be a screw and you need to tight it. Then if you tight the screw, then this city will be shortened and the current will be flow like this. Okay. So as the current is flow like this, then you can disconnect the energy meter to test or anything. Okay. So this is how the test terminal block is working. Now the energy meter, three-phase energy meter. Three-phase energy meter has 10 contacts like R phase main, R phase load, Y main, Y load, B main, B load. And between CTs, there will be a PT, R phase PT, Y phase PT, and B phase PT, and the PT neutral. So this is how the energy meter is connected in the control panel. And as we have seen D11, so D11 will come to the R main and return from uh, R load to the neutral, as we have seen. And PT will be connect to the middle one of CT connector. Okay, so this is how our energy meters are connect in the control panel to measure the energy passing from the system. Okay, so this is how the energy meter works. Now, as the CT and PT wiring completed, in every panel there will be a set of TBs, which is called TB or X, and in the set of TB, one TB may be called TB.1, TB.2, or X.1, X.2, just like this. There is a one set of TB, X1. This all is the X1, and the first TB of this X1 is called X1.1. Okay. Now, PT is denominated by E in the power control panel. Okay, so wherever you see the E, there will be a PT, and R phase will denominated by 11, 31, 51, and 71. YB neutral. Okay, then every PT wire you will see in the control panel, which will denominated E11, E31, E51, and E71. That is R phase PT, Y phase PT, B phase PT, and neutral PT. Just like that, CT has the three cores, right? So metering core will be indicated by D, protection CT will be indicated by C, differential PT will be indicated by A, and bus bar protection CT will be indicated by B. So here R phase same like PT, and the wire will be D11 for the metering R phase, and same like others. If it is protection CT, then there will be C11, C31, C51, and D71, as we have seen here. Okay. Now this is the total wiring of the control panel for metering purpose. Now we are going to control purpose. So control purpose, we required an auxiliary supply of 110 volt DC and some of the AC supply for illumination and others. Okay, whenever the DC comes to the panel, it will be redistributed in some other circuits with fuse, just like indication circuit, protection circuit, closing and tripping circuit, annunciation circuit, and so on. So we will cover some of these in today's session. Here, the AC supply will be denominated by H, If there is a single phase AC supply, it will be H1 and H2. If there will be a three phase supply, then the three phases are H1, H2, H3 and H4. Somewhere it is written H0 for neutral and H1, H2, H3 for R, Y and B phase. Now the DC supply, the main supply of DC come to the panel will be coded as J, and after distribution it will be convert to the some another, just like this. J, so J is positive, J is J1, negative is J2, and after distribution indication circuit, if there is a indication circuit, the positive will be L1, negative will be L2. Annunciation circuit, the positive will be L101, negative circuit will L102. Closing and tripping circuit, it will be K1 and K2. The tripping 2 circuit, that will be K101, K102. Protection circuit will be K201, K202 and so on. Now, if we see the breaker closing and tripping circuit, how it works. Here, this is the breaker closing and tripping circuit. This one is the closing circuit and this is the tripping circuit. Here you can see the TNC switches. Okay. Here the 86 relay, that is called master relay. This is the trip circuit supervision relay and this is the breaker coil. You can see in the dotted line, whatever is in the dotted line, that is breaker, and outside of the dotted line, that is our control panel. Okay. So let's see the TNC switch. TNC switch is a trip neutral close switch, in which there is a NO contacts. There will be many NO contacts which may close when this plunger will uh, we set this plunger to the close side or the trip side, just like this. When we set this to close side, these three contacts are convert from normally open to normally closed. Then whenever we remove from the close, the contact will two contact will be open and one contact will not be open. After that, when we convert this to trip side, then it will be convert like this. Whenever the TNC switch we took to the trip side, then this contact will be open. This contact is a NSC contact, which is used for some other purpose, which we'll see in the next. So what is this? The TNC switch will close the breaker and trip the breaker. How it works? Then we need to give positive to the one contact and take another contact to the breaker closing coil. Same like the tripping coil, and the NSC contact will be used for the auto trip LED. Okay. So here the TNC contact is given to the remote trip of the breaker circuit, and the close contact is given to remote close of the breaker circuit. Here the auxiliary switch of the breaker, and auto trip is a indication when you try to close the breaker and somehow breaker will not close, then this LED will be glow. So you may understand that something is happened, due to that my breaker is not closed. Okay. So this is how the TNC switch works. Now, the second one, master trip relay. Master trip relay is a relay in which uh, all the relays give command to master trip, and master trip will give command, tripping command to the breaker. Okay, in master trip there is a operating coil and some of the contacts which may be NO or NC. In the 86 relay, one side of the coil there will be negative always, and the second side of the coil the positive will extend from some another relays like overcurrent, differential, glucose, and any. The contacts of the breakers are used. Just we have seen that in the breaker closing command there is a 86 contact relay, 86 contacts of the 86 relay. As the 86 is reset, then and then our breaker will be closed. The another contacts are used to trip the breaker or to announce the annunciator that the 86 is operated. So the wiring is done like this. The positive is here, then the positive will extend to the breaker to trip the breaker, and a common from the annunciator will connect here. Whenever uh, the contact will change position, the annunciator will be glow in one of the window that the 86 is operate. Okay, so this is how the 86 master relays work. Now the trip circuit supervision relay. Trip circuit supervision relay, why it is required? So in any condition, breaker on or off condition, my breaker should be ready to trip in all conditions, right? So we need to supervise that my breaker is ready to trip or not. There is a provision to provide a trip circuit supervision relay. How it is work? There is a three coil in the trip circuit supervision relay. One coil is for pre-close supervision, second coil is for post-close supervision, and the third coil, that is C, that is indication coil. Okay, so anywhere if the trip circuit is not healthy, then the C coil will operate and it will give indicate that the something is happened in the trip circuit supervision. Okay, the wiring of this trip circuit supervision relay is to be done like this. Here in the C coil, we need to provide a negative always, and the positive will be extended by these both contact whenever it operates. Okay, so C coil will be always operate in the pre and post condition. How it is work? So the A and B coil is always getting positive from the panel, and the negative will become from the breaker side. How it is can, let's see here. The breaker has negative in his tripping coil always be there, and after the auxiliary switch of the breaker, here is the contact for pre-close supervision which will be connect to the our pre-close supervision coil at here. Okay, now the positive is here, so this coil will be energized, and due to that the C coil will also be energized. So this is how the trip circuit supervision relay works. And for the on condition, when breaker is on, the post close supervision will be come from here. So this is how the control circuit of the breaker is works. Okay. Now the protection circuit. So the protection circuit, the positive will be K201 and K202. And what are the protection schemes in the power transmission? There is the transformer auxiliary protections, overcurrent and earthquake protections, differential protection, LBB protection, busbar protection, REF protection, distance protection for line, and any other special protection may be required at that position. Okay, then we'll see the first auxiliary protection. So what are the auxiliary protections for the transformer? There is first Bucos relay. Everybody knows the Bucos relay is between conservator tank and the main tank of the transformer. Okay, then the OTI and WTI, that are that will be in MK box of the transformer. Then the PRV relay, that's a pressure release valve for main tank. It will be connect on the main tank, and the OLTC PRV, that will be connect to the OLTC tank. Then OSR, oil surge relay, which will be between the OLTC tank and the conservator tank. And the last is the MOG, that is the magnetic oil level indicator, which is connect to the conservator tank. So these are the protections, auxiliary protections of the transformer. These are the some of the auxiliary protections. How its wiring to be done? So in the Bucos relay, there will be two contact, one for the alarm and one for the tripping, which is connect like this from the TBs. Here in the T1, we will provide a positive. When the contact is closed, the positive will be extended and some of our relays will be operated. Okay. And all other relays are connect like this in the transformer auxiliary protections. Okay. How the our auxiliary protections relay work? Let's see. The three element relay is just like the 86 relay, one operating coil and some contacts, maybe that NO or NC. And now we connect our Bucos relay to the to this coil. How it connect? The coils will get negative from the panel itself, and the positive will be come from the Bucos relay. In the glucose relay, we have given a positive by the another wire, which is extend and come to this coil. This coil will energize and the glucose relay will operate. As we have seen that the 86 relay is operate the breaker. So here in the contact, we provide positive to one side, and another side there is a master relay coil, and master relay coil get negative from the panel. So whenever the Bucos relay will operate, the master relay will operate and our breaker will be tripped. Same like the annunciation of the Bucos relay will be given by annunciator in the window first, F1. Okay, so this is how the wiring of the auxiliary protections may be done in the control panel. Okay, just we have seen that the positive from the panel come to the every relay, every K1, and from the Bucos it back with K21 and come to the auxiliary relay, right? And the auxiliary relay will connect to the 86 relay. So this is how the wiring of the auxiliary relays are given to the control panel, and this is how the another relay are connected to the transformer and control panel. Okay. The differential protection, everybody knows that differential protection is the protection of the transformer. In at here, I have taken an ideal transformer, and ideal transformer gives the total output. So here in a first coil and a primary coil, there is 100 ampere, and secondary coil is releasing 200 ampere, uh, and we have provided the CT 100 by 1 and 200 by 1. So the 1 ampere will be in secondary, and this will be secondary current will be supply like this, and here in between that there is a differential relay. So whenever the current difference between these two, the differential relay will be operate like this. If the outer side fault, there is a fault of 2000 ampere, then 1000 ampere will taken by this coil. Then the secondary of the coil CT will be output will be 10 ampere. Then 10 ampere will flow in this circuit. But the differential relay will not operate, as here the 2000 ampere is outgoing, right? So this CT will also produce 10 ampere. So the differential relay will not operate. But in the condition when the fault is in between the transformer, then the differential relay will be operate like this. As here it produces 10 ampere, but at here only 1 ampere will produce, because the 200 ampere is the fault current inside the transformer, and hence the transformer differential relay will be operate. This is the single phase transformer. When there is a three phase transformer, the circuit will be like this, and in the same condition it will not operate in outer side fault, but it will operate in inside the transformer fault. That means between two CTs of the transformer bay. Okay, so this is how the differential relay operates. Okay, now REF relay. So we have seen the differential relay. Differential relay will protect from one city to another city. The total area of protection will be between two cities, right? But in REF protection, there is a bushing cities, the BCT. There is a city inside the transformer, and this is like that. This will protect only the winding of the transformer, like this. Okay, so this is the REF protection. REF protection is always in the star side of the transformer, and it works like this. As there is 200 ampere outgoing from these coils, then 1 ampere will produce in all three phase, that will come to here, but it will not be summation like 3 ampere, due to the three phase, and the algebraic sum of the three phase current will be 0. So here the ampere will be 0, and in neutral the ampere will is always 0 in the normal system, right? So the current pass through the this circuit will be 0. But if the outer side fault occurs, then the current of outer side 2000 ampere will go to the neutral of the transformer. So the current in the secondary will be 10 ampere, and the neutral city will also produce 10 ampere. So our RF protection relay will not operate anytime. But whenever the fault inside the transformer, then the RF protection relay will operate as the neutral city will get 2000 ampere and secondary will get 10 ampere, and this is how the RF protection will operate, as here the ampere is summation of this ampere will be 0 and here is 10. Okay, so this is how the RF protection works. Now, the overcurrent and earth fault relay. This is the basic relays of the transmission system. This is the old one relay, which is electromagnetic relay. And in these relays, you can set the current passing through the our system. It is depend on the CT ratio. If the CT ratio is 300, and if you want to pass the current from the system 300, then you need to set 1 as a plug setting. Okay, and if you want more, then 1.25, and if you want less, then zero point 0.5 or 0.75. Okay, and also there is a time setting which can be reduced or rise as per the requirement of the system. Okay, these relays is works on IDMT relay. IDMT characteristics, that is the inversely definite minimum time. That means whenever the current will be high, the tripping time will be less, and whenever the current will be less, the tripping time will be high. That is the inversely definite minimum time characteristics. Okay, as we see, the all the protections of the transformer and the uh, backup relay, so it all give command to the 86 relay, and 86 relay will operate the breaker to trip condition, right? So this is how our total protection circuit works. Busbar protection, that is the substation protection system, in which here there is a bus, and here it is shown that some currents is inflow in the bus and some currents is outflow from the bus. Okay, so busbar protection is works as like as differential protection. If there is a difference in inflow and outflow, the busbar protection will be operate, and all the connected feeders to the bus will be tripped. Okay, how that is work? So all the cities of the uh, every feeders outgoing or incoming from the bus will connect parallelly, and in between that the busbar protection relay is placed. Okay, and uh, this is the secondary ampere, shows that how the secondary ampere will be flow from the protection circuit. There is a 2 in and 2 out, so the relay will be not operate. But if the uh, fault inside the bus, then the difference will be more and the relay will be operate. Okay, this is the single bus system. In the substation, you can see the single bus system, double bus system, and 3 bus systems in the substations, and all the buses may be protected by bus bar protection system. Okay, now annunciator. So we have seen all the protections. Now annunciator will give us the announcement that this is operated, and how it works. Let's see. In annunciator, there is a connections like F1, F2, F3 up to F6 for these windows, and the common, whenever you connect common to F1, the first window will be operate. How the wiring of this done is like this. Here the auxiliary wiring of annunciator is done, but for the window wiring we need to connect each and every relay's contact, right? Here the differential relay is here, so we get common from the CC and give to each and every relay, and then we get another wire from the another contact and give it to F1. So whenever the differential relay will operate, this contact will close and F1 LED, F1 window, that is the differential relay, will indicate us that this relay is operated. And this is how all the relays are connected to the annunciator. So this is how annunciator is works. Okay. Whenever you accept, this will be stopped, and this is how the annunciator works. Actually, I have go very fast due to cover all the slides. But if you want detail uh, for these all the things and many more, you can visit this site Inside Tech on YouTube. This is the channel where you can get detailed protections, metering, reactive power, transformer, cooling control, OTI, WTI, how they are works in a simple language. Also, you can get the transformer protection, transformer testing, how to test the transformer. That is also covered in this YouTube channel. So you can visit this channel for many more things. Okay, then thank you to join me, and thank you Aurora sir for giving the opportunity
Thank
for
you.
this webinar.
Thank you,
Thank you.
Abhishek ji. And I would like to say that that was very informative, direct from the field. You have given the practical aspects, insightful, and last but not the least, the excellent presentation from your side. You tried to cover almost all the things required so far control and protection systems of transmission system is concerned. I would like to add three things. You have mentioned that the cities have three core. In big substation, it has four core or five core, depends on the applications and the network you have. That is there. And apart from that, I would like to add we have to always refer IC 61869 Part 1, Part 2, Part 3, Part 5 to have this instrument transformer information. Important thing is that when the voltage level becomes more than 66 kV, we don't use PT, we go with the CVT because that is comparatively economical than that CT we have in the systems. And the important thing when you talk about the neutral point connection with earth of all the instrument transformer like CT and PT, earthing and grounding of that connections plays vital role where to make that earthing, how to make it solid and how to ensure the proper connections of that earthing system instrument transformers plays a vital role. Apart from that, the DC systems, that is the heart, that is always connected with your battery bank and the chargers. Upkeeping of that battery DC systems is quite important to ensure the proper protection and control of power flow. We are also using devices like reactive power control, capacitor banks, reactors in our systems to take care of the reactive flow and to control the flow of reactive power from my systems because we can't impose the reactive power in the systems like anything. There are some penalties are also imposed as per the rules. Then comes the important settings of the relays we have and the coordination of relay in the systems. That also plays vital role. Apart from that, we have to understand how to decide the burden of that CT and PT. And after understanding the burden, we have to understand the difference between a metering city. You have talked about zero point 0.5 class in big station. We have gone with zero point 0.2 and zero point 0.2 S class also.
Yes.
That is also there. And when we talk about the special protection like direction elements are given to your overcurrent relay, how that direction elements are inserted and that ensure the proper operations of the relays when it is required, then proper condition monitoring of the breaker, gas pressure, spring healthiness, motor healthiness, whatever the mechanism is there to operate the breaker must be monitored. And very important part you mentioned, trip circuit supervision 95. That plays a vital role because your tripping circuit of breaker should always be ready to take command from any relay. And that should be always ready for that command, and that can be supervised by supervision relay. Very beautifully explained all the aspects. And you have already mentioned that this was just an overview in very short time. Because of the paucity of time, you can't cover the complete entire aspects of power protections and
Right.
control in one small webinar of 1 hour. And we are grateful to you. Now time to take question, and if anyone has any question and Abhishek is here to answer that thing, kindly raise your hand, we will unmute you and you will be able to talk one to one directly with Abhishek ji. Kindly raise your hand. Then might, yes, one person with the name TC has raised hand. Uh, Gulab, kindly unmute him. Sir, we are unmuting you and you are free to ask the question. Yes, sir. Kindly unmute, sir. We have given you right to unmute. Please give your introduction, then start asking.
Uh, am I audible, sir?
Yes, yes, please.
Very good evening, sir. My name is Chospel. So just now I've seen in the control circuit, there we have used the phase as well as or neutral or the positive as well as in neutral. I mean negative side we have used the fuse. So quite often I have seen nowadays people are using MCBs and that too we should opt for a single pole MCB or double pole. And in case of single pole, what they use, they prefer to have a neutral link, obviously. But is it the right to disconnect the neutral, sir, in double pole? Am I clear, sir?
Yes, yes. Abhishek ji, would you like to answer or should I answer it?
If you can, sir, you can.
Okay. When you are not using the fuse, you have replaced it with MCB. In both cases, the important thing is the proper rating. And first of all, you should understand the total burden of that circuit. And based on that, you have to select the MCB or the fuse. Because when required, something happens that should be ready to operate, that should blow, or the MCB should trip when some abnormality happens in the that circuit. First, that is the most important thing. Selections of MCB and coordination of that MCB and fuses, whatever you are using, plays a vital role. Am I right, Abhishek ji?
Yes, absolutely, sir.
Sir, pardon me. My question still remains unanswered, sir. My question is regarding the neutral or the negative part. Are we supposed to disconnect the neutral as well, sir? In case of AC control circuit.
Yes, yes, it is better to use two pole. That will be better. There is no harm in using two pole MCB at all.
But quite often, sir, I've seen neutral linked is being used. So, in any ways, I agree with you. Double
I,
pole,
I can I can
more,
tell you the
more
reason.
protection.
I
Yeah.
can Whenever the vendors submit a drawing for approval, you can make that necessary change at the time of submission of that drawing to your utility. And you can ask vendor to provide that MCB pole, nor the neutral link, definitely he will provide. And that ensures safety. There is no doubt about it.
But again, sir, again, like I'm not convinced with this one. Is really a neutral? I mean, if we isolate the neutral, in that case, is it like safe practice to isolate the neutral, sir?
Yeah, it is always better to isolate both the poles when you are going to perform any maintenance activity.
Yes, had it been the case, if it is sourced by two sources, in that case, sir, I would understand. Obviously, we have to isolate the neutral if there are two sources. But when there's a single source, are we still like going for a double pole then?
Uh, Definitely. I have one practical examples of not isolating isolators. Sometime, if everything is okay, there is no problem, there is no leakage of any positive and negative in your system. Nothing is going to happen. But sometime what happens, there are some leakages are there, your negatives are grounded, positive are grounded. You can't ensure safety in that case. If you are sure that there is no grounding of positive and negative systems in your systems, you can do it. Otherwise, I don't recommend. We should isolate both. Abhishek ji,
Okay, sir.
say on that. Abhishek ji, what do you have experience on that?
Yeah, yes, sir.
What do you say on that thing? What do you experience?
Actually, whatever we require to isolate, that should be totally isolate.
Yes, we should not take a chance at all.
Yeah. So and two pole MCB is required at that time.
Agreed, sir. Thank you.
Amit Yadav ji, kindly unmute and ask you a question directly.
Good evening, sir.
Good evening.
Hello, sir. You have mentioned that about PT and CVT in the 66 kV class and above 66 kV class CVT we are using.
Right.
In what sense you were saying that I am not able to understand that?
Okay. Okay. When when the voltage is more than 60 kV, first thing is the size of PT will be more. Secondly, what happens in basically CVT itself is a kind of PT with some capacitor, that is a capacitor divider.
Hmm.
And when you are using capacitor divider, instead of complete core to reduce that 110 volt or 132 volt or 220 kV to 110 volt directly, number of turns will be more. To avoid that thing, it is always economical to use some capacitor divider. After that, you use some transformer in that CVT to use for your metering as well as for protection system.
The purpose of CVT and PVT both are different in the substations, no?
No.
No, no. The only additional purpose of CVT is that can also be used for communication system.
Yeah.
You have
Hmm. But can we use CVT for a PT also?
definitely no doubt about it.
100%.
100%.
All the there are present codes. All the codes are present in the CVTs.
Right, right. You
That
can use all three cores.
so why are we using PT and CVT both in the 220 plus substations, 66 kV plus substations? In many of the most of the substations, not many of the substations. In most of the substations, we are using PT as well as CVT.
We are using PT up to 66 kV, and about that we are using CVT for the same
No, sir.
protection.
I'm saying for 220 kV class only, EHV class only. In EHV classes, substations, many of the substations, mostly I can say 90% of substations, we are using PT also and CVT also.
Abhishek ji, what do you say on that thing? Have you seen PT for 220 kV?
Yeah, it is actually it is connected to bus side.
But not on the
Yeah.
line side, I think.
Huh?
It is
Sorry.
not connected to lines.
No, it is connected to line whenever the communication is required.
No, he is talking about 220 kV PT.
Yeah, yes, sir. It is connected in many of the substations. Bus PTs are used till the date.
Okay, okay.
Yeah,
But in our systems, we are not using it because of economical reasons.
right.
So, but in that where the stations where you are not using, CVT is connected with the transmission lines. Agree?
Yes, it is connected with bus also.
Bu bus also.
Yes,
Yes,
there is no
Man,
problem.
means you are using CVT for bus in place of PT.
yes,
Yes,
it is.
Okay.
In some of the 400 kV, it is used.
we are
Okay, I have
using it.
not worked in 400 kV. That's why I am not aware of
No,
that.
no, we are using it.
Okay, okay. Agree, sir.
Welcome.
Thank you, sir.
Any more question? Neeraj sir is there. Bhatt Sahib is there. Uh, uh, if you have any question to ask, Umesh Yadav ji, Vaibhav Jain ji. Yes, Yadav ji. Umesh Yadav ji wants to say something. Please. And I would like to introduce Umesh Yadav ji. He is basically from Protection Divisions of Delhi, and he can throw more light on the issues we have. Yes, sir.
तो जय हिंद टू ऑल।
Yes, Jain.
तो मेरा अभी ये क्वेश्चन था कि अभी पीटी की बात हो रही थी,
Hmm.
हम लोग सीबीटी कनेक्ट करना ज्यादा recommend करते हैं।
आपकी वॉइस ब्रेक हो रही है।
पीटी की बजाय सीबीटी कनेक्ट करना ज्यादा बेहतर और उचित मानते हैं लाइंस के लिए।
बिल्कुल, मैंने भी यही बताया। मेरा भी यही व्यू है।
नहीं, इसमें मेरा एडिशन ये था सीबीटी लगाने का, वो इकोनॉमिक एस्पेक्ट का अलग इशू है, क्योंकि 33 केवी की सीबीटी कम अवेलेबल है,
जी 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 जी
60 एंड अबाव की अवेलेबल है।
जी
परंतु उसका एडिशनल बेनिफिट ये है कि जो हमारी लाइंस होती है, मोस्टली जो फीडर्स होते हैं जो आज की डेट में आ रहे हैं, वो इंडोर टाइप होते हैं।
हम्म।
तो सीवीटी अगर लगी है तो हमें केवल एमसीबी ऑफ करके सीवीटी की और उसको लाइन को हम चार्ज टेस्ट कर सकते हैं इजीली इन केस ऑफ एक्सेप्ट ऑफ पीटी।
ओके ओके
पीटी पीटी के केस में हम लाइन को टेस्ट नहीं कर पाते, उसको आइसोलेट ही करना पड़ता है।
ओके 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 ओके
तो दैट्स व्हाई
Due to
दैट इज
testing of
एडिशनल, दिस इज द एडिशनल बेनिफिट ऑफ द सीबीटी।
जी जी जी, थैंक यू उमेश जी, थैंक यू वेरी मच फॉर योर इनपुट।
इसके अलावा डीसी एमसीबी की बात कर रहे हैं हम। डीसी एमसीबी के अंदर नेगेटिव और पॉजिटिव दोनों के लिए इंडिपेंडेंट सिंगल पोल एमसीबी चाहिए, ना कि डबल पोल, एज पर आवर ओपिनियन।
दैट मीन्स बोथ शुड बी आइसोलेटेड। माय पॉइंट वाज बोथ शुड बी आइसोलेटेड, पॉजिटिव और नेगेटिव दोनों को आइसोलेट करना है।
नहीं, जब हम काम करेंगे तो दोनों को ही आइसोलेट करेंगे,
जी जी जी
दैट इज द रिक्वायरमेंट।
जी 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 जी
but
जी
but in case of many times there are sometimes negative leakage, sometimes positive
जी
leakage.
जी
In that case we can the identification of the leakage is
दैट हेल्प
problematic
पिनपॉइंट
in
द
double pole.
प्रॉब्लम। ठीक है, नोटेड।
और any other?
नहीं, थैंक यू वेरी मच, थैंक्स अ लॉट।
बाकी ये है कि आप लोगों ने इस वेबिनार में बहुत कुछ कवर करने की कोशिश की है, परंतु सब्जेक्ट इतना बड़ा है कि आप लोगों को करना इतना इजी नहीं है,
जी जी जी
क्योंकि एक एक टॉपिक भी एक एक दिन के लिए होता है।
जी जी, यू आर
और
राइट।
आपने तो पूरा प्रोडक्शन ही एक दिन में कर दिया।
ठीक है सर, थैंक यू फॉर योर।
ओके।
With that, I would like to say thank you to all the participants who have come here to join meeting out of their busy schedule, and a very special thank to Abhishek ji for sparing his invaluable time and giving very insightful, excellent, informative, and practical presentation so far control and protection of lines are concerned. Thank you, sir. Thank you, everyone.
Thank
Thank you very much.
thank
Thank you
you.
very much. Thank you.
Thank you.